Okay. So in offline mode, what you have to do? You have to restart all the services once the changes are successfully implemented. Then you have to deploy the changes, restart all the changes, then only your RPD will be present and RPD will be used by your Oracle BI server to make queries. Whereas in online mode, you are making the changes in server memory directly. You need not to restart any of the components. In the application, there is an option called reload server metadata. So just click on reload server metadata. Once you check in the changes, all the changes will immediately take effect without restarting any service. Okay. So keep in mind, offline is making a local copy of RPD and making the changes in local copy, whereas online is directly making the changes in the server copy. Okay. Now, let us.
Is it a best practice to use offline or online?
Okay. Best practice is making the changes in offline mode. Okay. We generally don't prefer doing online. If the changes are very minor and if you feel that restarting the services is like a burden, then you can just open it in online, make the changes and check in the changes. But before making any change, make sure whether in offline or online you are taking a backup of your RPD. There is a chance that we will make many number of changes, and if the changes are inconsistent, what we do, you cannot use your RPD in your enterprise manager to deploy. Okay, it will not get deployed. Right? So just take a backup, then start making. Most preferable way is offline. And even online changes also you can do. It's up to you.
How do you take a backup?
Just you can a normal. How do you take a normal file backup? The same way. Like go to middleware instances. Instances 1, BI foundation, BI server component, core application repository. Just copy this and paste this. It will be like RPD copy. You can just rename it as today's date. RPD as 20. Right? You can give a particular name to this. So you can see this.
What is the difference between RPD and RPD.save?
RPD.save, it will see your tool itself will automatically save few copies. It will take few backups. Okay, so you can use even if you .save, if you remove this, right, .sav, it will still act as .rpd file. You can even use this as this also as .rpd file after removing this extension. Okay, so this is a tool automatically taking backup for your for safety. That's it. Okay. So each time when you deploy a particular RPD, the previous RPD copy and everything will be saved. Okay, a copy will be created. Fine. Okay. This is fine. Next, what you can do, we will just see the different components that are present in our RPD. So open a particular RPD in offline mode. We have so many RPDs, right? So open any one of the RPD. You should give the repository password. Okay, you should remember it. While creating repository, you might have given this. Okay, now let us see the different components. This is, see, there will be 3 layers initially. If you don't want to look into a particular layer, there is something called view, presentation, business modeling and physical layer. If you don't want to see presentation layer, just uncheck it. You can only see 2 layers. If you don't want to see business model mapping layer, just uncheck it. If you don't want to see physical layer also, you can uncheck it. So this is your administration tool, which already your RPD is in open state. Go to view and look at your physical, business model and presentation. So all the 3, just keep it make it visible, and this is called a data source. Okay. Now when I expand it, then you can see something called as supplier CP, which is called a connection pool. This is called physical schema. Supplier 2 is a schema where all my tables are present in my database. Okay. So we will just explore what are all the different types of tables and what are all the different types of objects that we can create in our physical layer. Okay. Next.
All these files will be there in the system itself, the table like the schema file?
Which one?
Or it will be get it from the server? All the tables we have to get it from server, or it will be there in our system?
It is there in our system.
Okay. But this will require a lot of storage place, right?
No.
So it won't be an issue?
It doesn't require a lot of storage space. Why do you require a lot of storage space?
Because the table can be huge, right?
No. This is okay. You meant to say in real time, right?
Yeah.
See, here we are not storing any table. This is just telling that you have a table in particular data warehouse. That's it. And you are defining all the server details. It may be present on a different server as well as on the same server. It may be present anywhere.
So the supplier CP is, can you explain again what all this?
1 minute. I'll slowly explain. Just now we started, right? I'll slowly explain everything. Okay, just keep in mind this is a data source, a connection pool which gives connection details to your database. Supplier 2 is a schema which contains all the tables. Okay, fine. Up to here it is fine, right? Now I'll slowly explain how the tables are there. This is just metadata. Your physical layer or your OBIEE does not store any data. This is just like you are referring all the objects which are already present in your data warehouse.
But in real time we have so many schemas, no, Janakya?
Yeah. Create multiple data sources, create multiple connection pools, import all the schemas. It is not like only one you can have under ORCL. You can have multiple schemas. Okay. So yeah, just look at the objects first, then slowly we will make it complex. Okay. Now, first we will see the properties of our ORCL database object. Okay. So double click on that. You have something called general, which is the name of a data source or database. Okay. And the database type is OBIEE11g. And you have features, the different features that this database supports. Okay, you can find, suppose if you want to see something called intersect function, whether it is supported, this is a set operator, right? So if you want to see whether this is supported, just find it. There is something called intersect supported. Is intersect supported? Yes. So by default it is supported, and value is like you are overriding the default property. If you unselect it, even if the default is selected, you will not be able to perform any select operation on this database. Okay. Now, what are the connection pools this database has? One is supplier CP and one more is variables. Okay, we will see how to see. We will start from the initial creation of our data source. Everything will start from that. First, look at all the objects. Then, once you are familiar, next session itself we will start bringing in all the tables and everything. Okay. Next. So you have something called display folders. As of now, there is no physical folder in your data source. And you have database properties. As of now, we didn't set any keys or any property here. Okay. So we'll just see different types of features. You can see AND is supported, OR is supported, NOT is supported. So all these are our logical operators, right? So all the values are supported. So like this, when you have different types of features, you can see whether a particular feature is being supported. So union is supported, union all is supported, count district, count star, sum, average, first, last, rank, all the group functions, and your joins like left outer, right outer, full outer. So all the joins, everything in whatever you want to perform a particular operation or to write a particular query, all the functionalities have been supported by your database features. Okay, you can see that. If you don't want to, suppose if you don't want any sum or average function to work, you can come here and unselect it. Otherwise, just keep select. Okay. So generally, it is not advisable to change anything. Okay. So features by default, whatever a database supports, all the features will come in. We need not to change any of the features. Okay. Fine.
So this feature will automatically get crowded once we upload the, like we connect the database, like connection pools.
Exactly. Yeah. We will not change anything here. Once our database is created, see with respect to if it is an Oracle database, it has some set of common features, right? So all those features will be highlighted. If this is with respect to Microsoft SQL Server, when you import a particular table or anything, automatically your database is also created and all the corresponding features are also imported. Okay, so we are not creating anything. Whatever is supported by them, they are just getting displayed. Okay, so when you find some issue with your operation, you can come here to features and check it. Okay. Right.
So can we enable any features or no?
If it is not default, right, you cannot enable anything.
Oh.
You can unselect it, but if it is not default, you cannot enable it. Suppose say here you have some functionality called moving average, right? So this is called a moving average, which is not at all supported by your database itself. So your value also, even if you select, it's of no use.
Oh.
Okay.
And the name like ORCL, it's like you have like we can give it according to our option, or it will.
Yeah, you can give
as
whatever
ORCL.
you want. Yes, you can give whatever you want. Suppose here we will see.
Will these features be common for everything, or we have to specify?
This will change with respect to our database. You need not to specify anything here.
No, if we check it here, I think that is what which is going to enable us. But all features going to be present for every database I create, or what? Database properties I do, or what?
Pardon?
See, the feature whatever is listed on the left hand side,
Yeah.
will it be same for everything? All I have to do is on the right hand side.
It won't be same for all the databases. It changes with respect to our database.
How does it then? How do you enter a feature? Like you want so and so feature.
No, you don't enter any feature. Why do you enter a particular feature?
No, see, if there is less than supported, right? Less
Yeah, okay.
underscore.
It will be same name. It will be same name for multiple databases.
That's what I'm saying. See, if that is a feature actually, you say I can add a feature or I can disable a feature, right? I cannot disable a feature.
You can do it. See, the value is selected here, right, for this.
Yeah, that's what I'm saying. If you unselected it, it will not support our whatever the data which we are going in this.
Yes,
That's
it will not
right?
support. Yes.
But the features will be there for any set of things. These are the features which are going to be available.
Yeah, these are the features which are going to be available. Exactly. Now, what is the question actually?
I wanted to know these features are there for every database like this itself, or like we enter like to request to support except underscore supported or greater underscore equal than.
Yes,
we have
yes.
to write like that, or should we write them, or those are by default features which come with the database?
Those
If
are
we
by
just
default. That is what I am
for
telling
this
you.
or not, we will select it.
Yes. See, I am telling you from the beginning. These are the features by default which comes when you import a particular database. Okay. So you are not creating anything. Any database object when you import, when a data source or database is created in your RPD, all the corresponding features are pulled in. Okay. You are not creating anything on your own.
Okay, gotcha.
Yeah. Fine. So this is something about database features. Okay, you can see features tab. Then under connection pools, display folders, everything, you can check all the objects which are present. Next, explore the properties of your connection pool object. So cancel this. Look at your connection pool objects. So this is called a connection pool, which provides the details of your data source as well as the username and password with which you can access your database. Okay. If the connection pool information is wrong, even if you have everything properly defined, you cannot connect to your database and make analysis. So make sure your connection pool has all the proper username, password and data source. You can see your database is something like this, which is the full description from your TNS entries, and you give a particular connection pool, and call interface is like a default Oracle call interface, or whether it is a ODBC connection or anything, and maximum connections at a time are 10. Okay, what it does, it allows 10 concurrent queries to be run in parallel. Any query which is coming after 10th will be in waiting state. Okay. Now data source name is the data source what you want to connect to. Username and password you have to give to connect to the database. And your connection pooling, you are giving timeout as 5 minutes. That is, if you are not giving this enable connection pool, each and every time when a user requests a particular request, it's an extra burden to your Oracle BI server to open the connection to your database. So if you tell that 5 minutes let it be in open status, then each and every 5 minutes, like a particular user is logging in and 2 minutes is not performing any operation, the third minute if a particular new user is coming and making a request against a database, you need not to wait, or you need not to send the request to your BI server to open the connection pool for you. Okay. So by default you can use the existing connection pool which is already been used. Okay. So here max you will be touching this data source name, username, password, and this call interface type, everything, and this enable connection pooling, use multi-threaded connections, parameters supported, we'll just select it by default. We won't make much of the changes here. Okay. Next. And a write back is not required as of now. So write back we are not going to implement here. So just this section we can see, and we can look into different type of options. And even you can select to, you can set permissions also. This permissions and security we will discuss it later, not now. Okay. So just go through this part. So you can see that your connection pool name can be changed and given anything. So you need not to only give supplier CP. However you feel comfortable, you can give this. If it is any real-time project, whatever the client requests, we will give that name. We don't give any name which is required on our own, but it should be of some certain standards, like data warehouse connection pool, or a client name connection pool appended with client name, and you write it as connection pool, something like that. So whatever standard you want, you follow that. You cannot give the name that you want. Okay, and it does not really impact. Whatever name you want, you can give it. Okay. Fine.
The data source name will automatically get crowded, or that also we have to?
This one, right?
Yeah.
No, this we will give.
Oh, we have to give.
Yeah, this we will give.
Then
This
how we will?
data source name, username, and password, everything we will only give it.
Okay,
Okay.
we'll come to know how to do that later, right?
Yes. We'll start from the practice how to create all these connection pools and everything. I will show you. This is just I
And
want
what
to
is that
show.
isolation? Mhm.
Yeah, what are the different objects present? So tomorrow when I say connection pool, you should not get confused. So for that reason, I am telling you what is a connection pool, what is a data source, everything. Okay. Fine. Next, here.
The connection pool will have for every schema we have one connection pool like that.
It depends. Suppose, see here in my database itself, with the same data source, I have multiple schemas in my database. See, in a class, you can have multiple students, 10 students, right? Each student is a schema. Your classroom is like a database. And you have one entry, right? Only one door you have, right? That is called your data source. With one door, you can have access to multiple schemas. Same way, with one connection pool, under it you can have multiple schemas also. Depends. If it is another section in the class, if it is like class 2, then you have to have one more connection pool and one more data source, right?
Okay.
So within this data source, you have one connection pool. You can have access to all the schemas which are there. If you say that if this is a different schema and this is entirely a different database, you can have a different database, different connection pool and everything. Okay. So like that. Fine. Next. Now we will see this is called a connection pool. This here we have all the different type of entries. Did I show you? Yeah. Next we will look at the different type of objects and the joins between them, and we will see the business model and mapping layer and everything. Okay. So even you have access to this, right? You can go through all those things properly slowly. Now open your, expand your schema. You have different types of tables. When I see here, I see something called 474 rows, right? When I see here, this I see called 38 rows, right? So when I right click on this, when I click view data, it asks me to select a particular connection pool. I am selecting supplier CP, select it. You will see data which is present in your table. Remember that table is not stored here. This is purely present in database. The database is called your Oracle database here, supplier CP. Suppose connect to your supplier 2 with supplier 2. So here you have something called select star from D1 underscore calendar 2. So when you run this, you have all the values like all day, year ago, month code, all the information, right? So here what you can do, you can just view data. The same view data function works here also. Why do you use view data or update row count here for each table? Because if you feel what this confirms is, this just confirms us that whatever the entries that you specified in your connection pool are proper. Okay, your view data or update row count, when they work fine, that means that the connection pool entries that you define are proper. Okay, fine. Next. So this is called a physical table, and when you expand it, these are called your columns. So what are all the columns present in your table? You can view them. Suppose say in future you are adding a new column to your database. Okay? In database, if you add a new column to this table, and if you want to see this in your RPD, it will not flow automatically in the RPD. You have to manually right click, create a new physical column, give the same name and data type that you created in your database, and check in the changes, then it will take effect. So first time when you import, at that point of time, what are all the columns present in your table? All the columns will get imported. If any new column is being created after the importing of your object, then all those values need to be created manually. Okay? Next. So this is called a database or data source, a connection pool, a schema, a physical table, a physical column. Now let us observe at how the joins are defined in your physical layer. So your physical layer is a replica of your database, right? So whatever is present in your database and the different types of joins which are present between all the objects, everything is there. So your physical diagram, when you say objects and direct joins, you should have all the type of condition within them. So you have something called D1 calendar YYMMDD column is being joined to fact D1 order historical period key. So a particular dimension key is referred by a fact table with primary key foreign key relationship, and you can see that dimension table is present on the one side of a relation here. Like you have n 0, 1, 1 and unknown, right? So on the primary key side you have your dimension. On the fact key side, you have your foreign key. That is the reason it is showing 1 to n relationship. For one value or one particular day, you can have multiple fact entries. That is the reason it is saying day joined to your period key and has multiple values. Okay, cancel. Similarly, you have joins defined between each and every column, and you can see that your expression is being editable and you can specify your join criteria accordingly. Okay, so keep in mind that your physical join condition or expression is editable. Okay, this when you right click and see physical diagram, objects and direct joins, you are able to see all the joins. Okay, so just have an idea about your physical tables and physical joins. Next, I am hearing a lot of disturbance. Keep yourself on mute, please. Okay. Okay. So I have next something called business model and mapping layer, and we even call it as a logical layer. So why do you call it? You bring in all the physical tables from your physical layer, name them accordingly with as your business terminology. Here you have your physical table name directly like D1 customer 2, but whereas in your business layer the same table is being named as your customer, okay, or DAM customer dimension. Okay, so this is called a logical table. This is called business model or logical model. This is called dimensional hierarchy. This is called a logical table. So in logical tables you have logical columns. Okay, so it is not a rule that your D1 customer table has suppose say 10 columns. This BMM layer may have only 5 columns. all the unnecessary columns can be avoided. If you don't want, if you feel that a particular column is not required for your analysis, you need not to bring it to your BMM layer. So you are more optimizing all the objects that are visible. Even if you have 50 tables in your physical layer, you need not to expose all the 50 in BMM layer and correspondingly in presentation layer. Alright? So what you are doing, whatever is present, whatever you want, you will name it with respect to business terminology and in most understandable way. Okay? So the joins between a present, this is the place where your OBIEE starts checking consistency. Physical layer, it does not check any consistency. So what does consistency mean? What happens? Always your dimension and fact should be joined. There should not be any table which is left without having a join criteria, and minimum there should be one dimension and one fact. Even if your physical layer it has only one table, your BMM layer should have two tables minimum. For the same table, you can give the same table as a dimension table as well as a fact table itself. That's a different concept. Slowly we will go there. But as of now, remember that this is a logical table. Below that we have something called logical column. You have something called sources. When you click on here, you have something called logical table source. Okay. See, we will create all this. You need not to worry. The only thing is remember the terms, remember the words. That's it. Okay. So here we call it as physical table. The same thing here we call it as logical table. This is called a logical table source. Okay. This is called a logical column. This is a fact table. This is a dimension table. And when I see my joins, fact cells, physical diagram, objects and direct joins. Sorry, not physical diagram. Business model diagram, objects and direct joins. You can see this is a star schema. Your fact cells is being surrounded by all the dimensions. When I double click on the join criteria, so what is the difference that you found? So fact cells is inside of the relation, your product is on one side of the relation, still it is 1 to n. But you don't have your expression editable. You cannot write any expression in your logical layer. Okay? In logical layer you cannot edit your expression. And in physical layer you can define the physical layer condition. Okay? And now coming to your presentation layer, what is presentation layer mean? Presentation layer is similar to that of your new analysis when you create, right? So now let me show you, let me open the RPD in online mode and let me show you the difference. So now I am opening my RPD in online mode. Okay, so to be open in online mode, all your services should be up and running. So all my services are up and running. Provide the repository password. So the repository can only be opened as read-only mode. Yes. So here you can see two subject areas or two presentation catalogs. So this is called a presentation catalog. So when you expand a presentation catalog, you can see a presentation table, and this is called presentation column. This is called presentation hierarchy or something like that. This is a presentation column. When you double click on this, and you can see logical table properties also. General, you can change the name, sources from which table it is coming, and what are the keys and foreign keys, like this. The same way in our presentation table also you have general, you have different columns, and you can arrange them. Whether it want to be up or down, you can change all the positions also. Okay. You have, if there is an alias for this table, you have aliases, hierarchies, what are present in this presentation layer, everything is present, okay? And this is called a presentation column, a presentation table, a presentation catalog. So what are all the values present here? The same thing you can see it in your application. Let me show you the application. So your application is Data BI Analytics. Log into this using WebLogic welcome one. So when I do new analysis, right? So ABC usage tracking as well as supplier sales. There are two values present here. So what are these? These are the subject areas which are present in your presentation layer. So now can you correlate? So see, I am displaying or I am exposing all the subject areas which are present in my presentation layer in the application. And how does this communicate? Suppose say if I click on supplier sales, here also click on supplier sales. So click on customer here, click on customer here. You have customer region, district sales rep, customer, region, district sales rep, customer, everything in order, the same order. So when I select it here, how the report is displayed. Suppose say when I select customer information, click on results, you have all the customer information coming in. So how do you select this in our RPD? You have customer, right? There is something called query related objects. You can go, you can see that this presentation column from which physical column it is coming. You can go to physical column. So this is coming from name, click on go to. So from DIM D1 customer to name, this is value is coming. Click on this, click on view data using supplier CP. You can see the same number of records, like 0. How many customers we have? You have 99 customers. The numbering starts from 0. Okay, so if it is with 1, it should be 100 customers. Here, look at this, how many customers are there? Okay, so total 134 rows are there. You are only seeing 100. Suppose say see 200.
Can't we say row starting from 1?
No, this is tool standard. I cannot see like that. Okay, here, yeah, here you can select it. Row starting from 100 or something like that.
1.
1 also you can do. So 200. So max it will be from 0 to 133 now. So you can see all the 133 values. Present here. Okay. So this is how you integrate. Now what happens? Just look at how you achieve this join criteria from presentation layer to your database. So let me show you in diagram so you will understand it better. Now can you correlate how your application and your RPD are joined? You know now, right? So your presentation layer is being displayed there and your presentation layer is there. From your presentation layer, your business model and mapping layer and your physical layer will help you to get the data from your database. Okay. Now you have like this. You have application or client here. You have presentation layer. You have business model and mapping layer. You have physical layer. You have a data warehouse. So from here you don't want about ETL and all. So here how the data is been coming. This is data warehouse. This is your physical layer. This is your BMM layer. This is your presentation. And this is your application. So whatever is present in your presentation layer, application will refer it. And your presentation takes the data from your BMM. And your BMM refers your physical layer, and your physical layer has all the joins, tables, everything, and connection pool information to connect to your data warehouse and access the objects. Okay, your physical layer to your data warehouse. Fine. So like this, you have your connection set up between your data warehouse till the application, and you can make analysis. Okay. Okay, like this, from DW to physical to BMM to presentation layer and to application. So all the phases, the data is going to deliver to your report. Okay, so this is a basic idea. What is your RPD? What are the different components present in it? Okay. And slowly we can move on to creating RPD, developing RPD and everything. Okay, now here. So next practice starts with building the physical layer of a repository. Okay. So this I want to show you. I think it is better to show it tomorrow. We'll discuss something else. Okay. So, okay, we'll start with this. I'll slowly explain. Today we'll read about the business scenario. What is our business exactly? So, how we are going to work with our RPD. So, how we develop it. Who is our customer? So, this is a practice customer that we have. So, what our customer does, what are the different hierarchies that are going to be present, the different types of sales information, revenue and inventory information, everything. So, we'll just see how it works. Now, so what is the background of our company? We are working on client ABC, which sells food and non-food items to restaurant chains in your United States. Okay, there are a lot of customers. As we saw customer table name, there are around 134 customers whom we are supplying our products. So we are developing different types of products under baking, under beef, beverages, grains, everything we are supplying to restaurant chains. Okay, and now it has so many employees who depend on IT team who generate reports to look at the performance of the organization. Okay, and ABC recognizes the importance of a business intelligence solution that will provide, and it is not mandatory for every organization to have a DWT, right? Warehousing is optional. If you want to look at how your business is performing, you can go for your warehousing. Otherwise, you can skip it. You need not to spend any money on that. But whereas your OLTP system or transaction processing system, is mandatory. That means it should be there, right? For your day-to-day operations also it should be there. So you cannot skip it. Whereas your data warehouse, if your client don't want, you cannot force them. Alright? It is up to them. Okay. Now, to achieve the goals, ABC has decided to implement OBIEE solution. The solution will enable its sales executives and operations manager, everyone, to look at the reports and take an effective business decision. So that they can improve their delivery or they can improve their products on daily basis. Okay. So business requirements are like this. Your managers want to use their own information. The company has little experience in data analysis. The database has approximately 350,000 invoice level records that span in the period of. Here we have 2008 and 2009, but our practice I have taken it as 1998 and 1999. So just don't get confused. Anywhere when you see 2008, 2009, just make the, while you are practicing, make those values as 98 and 99, 1998 and 1999, because the data was only available for those years for us. So that was the reason we dumped all those values there. Okay. And we have a schema to practice that is called supplier to schema. Here select star from user underscore tables. So when you do this, this has few tables under supplier to called D1 customer to D1 district. Everything is appended with D1 only here. You have to identify what is a fact and what is a dimension. That you need not to worry, because your PDF itself says which is a fact and which is a dimension. Even if your PDF does not say, it is pretty straightforward to us. Suppose when I do select star from D1 customer customer 2, this has all the customer information, and you can see that this table does not contain any of the measure, right? So this is a dimension table. You see something called orders. So run this. You have keys, you have something called 475.76, 567.59, 524.84, net weight shipped as the column name, units ordered as the column name, and you have some measures, right? So all these measures, you have it, that is the reason you call it as a fact table. So even if you don't know what is a fact and what is a dimension, look at their data and you make sure that if any table which has measures is a fact, any table which has just a descriptive information is called a dimension, and join the table with a fact table. And one more best idea is dimension tables will have very, very less number of records, whereas facts will have huge data sets. Okay. So anything, so it is up to you how you approach. But if you check the number of records, it's always not a good practice. Check the data. If you don't know a particular fact, generally your DW team will itself tell this is a fact, this is how we are loading it and everything. They will give you data model also, how the joins are present. So any join where if a particular table is present on n side of the relation, that means it has a foreign key. Mostly all your foreign tables which are having on n side of a relation will be facts in your warehouse most of the time. Okay, right. So this is something about our business, and they have ABC employees measures product data at different types of levels like total type, subtype, generic product and specific product. This is called dimensional hierarchy of product. And for your customer also you have different regions like total, region, district. You have your value started at total region, total, and then region like south, east, west, north, like that. And then east region you have again divided it into sales rep districts. Suppose if you take western region, you have California and so on, like desert, northwest, so all those districts. Then what you can go there? From district you can go to sales representative information. So you have 134 around the different types of employees, right? So each sales representative, a particular sales representative may be associated with one or more customers. One may be giving baking products and to all the customers, and one more may be giving beef products to all the customers. Okay. So one sales representative may be involving with multiple customers. So like this, your customer hierarchy has been defined. So all this you will collect it before developing your RPD itself. You have to collect it from business. So what their business is, how they are looking at their business terminology, what are they want. Everything will go through brainstorming, question and answer sessions, everything, and you collect all the requirements. Okay, fine. So you have different ways of collecting data, all the ways you approach and get the data from. Okay. Now, how do you build your business model? The same thing. You will have brainstorming sessions. You go, what are the hierarchies you want? What are the measures you want? So all this your business should be able to answer, because they want how their business is and they know how their business is. So they will tell you all. So once you collect all the requirements, all the facts and all the dimensions how they are, then you start with your practice. So creating repository and importing a data source. This will start our practice. This I don't want to start today, because once I start I will complete at least 3 exercises. So we have half an hour, right? You will get confused. I will start tomorrow. Okay. Is that fine, or you have any issues today? If you have any questions, you can ask me in repository. So from tomorrow our practice starts. Everyone should be having their missions. So once I complete my session, without fail, even you should be doing it in your